Welcome to another GCBASIC demonstration. This demonstration is specific to AVR DX and it could be generalized to AVR, and this is looking at EEPROM operations. We've had a EEPROM commands where you can read and write to the EEPROM from within a program, but this is going to be looking at blocks where we can write from the source code and generate EPP files in terms of writing direct to the EEPROM. New capability. Hugh never implemented this, so this is pretty new, and it's September. So what I've got attached is a C Nano board, and this particular C Nano board, I've been using drag and drop up to now, but it's actually got what's called an NE debug interface on it, and that's written just here. And that means I can actually program this, and I can program it in different ways. So I'm going to program this using sort of the drag and drop and just throw the file out, the hex file at the chip. But I'm actually going to do some proper programming as well today. What I'm looking at is what we're talking about specifically is this lump of memory, this 256 bytes in EEPROM. And if we structure the hex file correctly, and throw it at it, it will automatically program it for us, which is what we're going to be doing. So we're going to be able to create EEPROM data. We're going to produce EPP files directly now from GCASM, which is pretty damn good. And GC Studio can now has a programming extension to read and write, read specifically program memory and EEPROM. So what we'll do is we will review some source code. We'll look at the output and we'll use a bit of tables, a bit of EEPROM, but I'm going to start with EEPROMs and we're going to start with the use case. Okay, start with the use case is always good. What's that use case? Yeah, I've got some source program and a terminal. Let me get my source program up and my terminal, try and get them side by side. There we go. Oh, there you go. It's even better. If I just pause that terminal for a second. Right, in that terminal, it's got some data. It's got some data sitting in this hexadecimal view. It's got some data sitting here at 00, 31, 31, 32, 33, 34. It's passcode. I'm going to be using that in a moment. It's also got some other data sitting down at 40 hex. And how does it actually do all that? I mean, it just looks spectacular. Not really, but let me just bring that across. I'll zoom in over there. There we go. And how does it do that? I'm going to use this command called EEPROM. And it essentially just writes the EEPROM straight to the, creates a EPP file and programs it. So I've just commented this block here. So if I program it now, I've written a little program above here. All it does is show the data on the serial terminal. We can connect to it. It's programming it at the moment. We'll have a look at that in a moment. It's doing its programming operation. And now if I pause it, it says 31, 32, 33, 34, and there's nothing here because I took the block out. I took the block out the source code. It doesn't appear in the hexadecimal file. So if we look in here and I uncomment that and I change that to just this is a test, I will press function key F5 to program it, and then I'll look at what's happening down the bottom. I've got a missing quote. Yes, I have. I'll put that quote back in. You didn't see me do that, but that's okay. So what it's doing down the bottom, it said here that I've created an output file hex and an EPP file, and it's now using this specific interface that's been defined, and it's erased the chip, programmed it, erased the EEPROM, and programmed the EEPROM. So now we're looking back in the terminal. We'd expect to see something different when I connect it, and here is the string. So how would you use, and there's the string there, but you can see it, I'll just disconnect that. There's the string in memory, exactly where we put it at 040. How can we use that? Well, we can use it like this. We can have a little program that looks just like a passcodey thing. I've written one here as an example. All it does is reads the EEPROM and puts it in an array, and then just compares that array on a serial input. So if I just change my programmer, edit preferences, I'll zoom in so you can see that. I had the UPDI one loaded. I'm just going to change that to C nano. That means it won't erase the chip. It will just copy the file. If I press function key F5, it will actually program it. I've done it already. I'll connect it up to the terminal, and I'll just enter passcode on the keypad. We are looking at a completely new program. So I'm going to put in my passcode here. I'm going to type in 4 random numbers and send it in. It says passcode does not match. Press enter to start. That seems to be the important thing. It's just a synchronization I put in. You can really improve this program, by the way. Have a look. The passcode is correct because I entered in 1, 2, 3, 4. But it created the hexadecimal previously, and then it loaded the EPP using that new interface I've written to make sure that you can get the hex file in there. Now, what you can do is some really clever stuff in here. You see, look, you've got this hex file, and it's created GCBASIC creates assembler, and here is the assembled file. We know it's the assembled file because it's got this data called my data at the bottom of it, and that was what we put in it. Control A, Control C. I've started up, zoom in for you, I suppose. I've started up a project, an assembler project in Microchip Studio, and I'm going to just take that source that I just copied into my buffer and paste it all into here. And there it is, it's inside of Microchip Studio. If I compile that, build the solution, there are no warnings. I have to show you the bottom. There's no warnings, no errors, 21 warnings, and the warnings all refer to use of registers, okay? Doesn't really matter because we got no errors. We can program that. Now, how do I program this? There's the folder. You can see it on my desktop, and I'm in debug mode. I'll just turn that off. Release. I'll rebuild that for us. Great. It's now got a release, and I just want the folder name. It's created the hex file. It didn't create the EPP, so back into here. I'm just going to have to come back into here and change the project settings. Project EE demo properties. Build events, or was it tool chain? I can never remember. Tool chain general, generate an EPP file. That's great. Build it again. Back into the folder. We've now got an EPP file. In actual fact, it's the same as the one from GCBASIC, okay? But I'm just showing you can do it. So in here, I've got some files. I want to program it from here. Tool, device programming, apply, memories. Just take my file. Oh no, it already got it there. Look, it's got it. Has it got it there? No, that's wrong. But the EPP file was wrong, but never mind. There's the EPP file. There's the hex file. Erase the chip. Erase the EEPROM. Program that. It's got no. Remember, it's got. I'm just putting the same program in. And if we look down here, we've got the same program running, but look, it's gone back to the original program, which is a lot in GCBASIC. It's a lot quicker. It's the same program. I'll just show you that in same program again. If I wanted to program it here, function key F5, It generates the hexadecimal file, it generates the two hex files, and then it programs it. The one thing I have to ensure to do is to change it to the correct programming interface to get it to program it, because it will program it through the drag and drop interface, which will not program the EEPROM, which I'm now doing. So if I come out to here, it's just erasing the chip. It's done it. There we go. We're operational. And you may say, it's not doing it. Well, if I get rid of that and I change this to 4321, program it, we will see these four here invert once I reconnect my terminal. Four, three, two, one. So you can do it in GCBASIC, but I've shown you also you can take the same assembler and take it through the painful process of taking it through Microchip Studio to do the same thing, but essentially it works. A bit more complex. You've always been able to do what thing called tables in GCBASIC, and you can do the same thing. Okay, so in here, I've just uncommented it. It defines a table called my table, and it says store it. Now this has not been functional in AVRs. None of this has been, by the way. Store the data. You can put that directly into EEPROM. I will just get rid of that for the time being, just so we don't get confused. So it's going to put A, B, C, D in now. It's just going to program it for us. If we look at the assembly, we now have something called table my table. The data is slightly different, 4, 6, 1, 6, 2, 6, 3, 6, etc. But now if we look inside of here, our terminal, disconnect it so I can stabilize it. There is the same data. It's been moved in. Oh, that's right. It will pad it with a 0. That's the way it works. And that's fine. What we've got is a fantastic interface. We could read, write EEPROM data, creates EPP files. We can do a compare between the two. All the hex files are identical. That's really quite useful. So if we come into here and we reveal, this is the project I'm working on. Here's my EPP file. Oh, it won't be the same, will it? I don't know. Let's see if we can do this. I'll take that ASM. I'm going to rebuild it inside of Studio. Open the container. And here is the files. It's just created the EPP and the hex. I will do the same in here by opening up, revealing things. EPP and a hex file. I'm going to put them in the same folder as here. Compare the hex. So one file was produced by GCBASIC. The other one was produced by, get it all on the screen, Microchip Studio. That's the same. So this is doing a compare EPP files. I've got them out of sync. I've clearly got the two out of sync. What you can do, or it might have padded it. There might be some different padding. Let's have a look what the decode is between the two. So if we look at the decode on the one on the right hand side, the decode of that is here we go. Hold on a minute. I'm just trying to decode it. Please decode microchip hex. I'm just typing this into a smart engine. You can see the end one's the same. This is the same. Okay, so the one on the right is, oh, let's have a look at it. 4, 6, oh, that's the same. Oh, there's a 00 tucked behind it, of course. One has got a slightly different data format, which is not a problem, but we know that the hex files are the same, and when we load up the EPP files, they're the same, so that's really good. Back into my presentation. So what I wanted to show you was a bit of EEPROMing, some of the new functionality. Summary, we produce EPP files, we can easily write data using tables and using EEPROM. We've done through a use case, we'll call that wrap.